Next, we'll be looking at how you can elevate your business through data-driven decision making. Our next speaker is Mihail Musat, DevOps manager at Zitec, where his mission is to turn the company into a household name in application modernization locally and internationally, and help organizations make an impact with technology. Specifically, Mihail and his team help their clients efficiently bridge the gap between development and operations, streamline their delivery process, and ensure the best DevOps approach for their business and software applications needs. He will present a use case of Cars2Click that reached an ingestion of approximately 5 million events in under 40 minutes per day. He will show us how this collaboration between Zitec's DevOps and cloud consultancy teams and Cars2Click helped to reduce the processing time, improving their data management from 2 hours to 5 minutes. Welcome, Mihail.
Thank you. Okay, thanks, Cesar, for the introduction. I was trying to following it, but it's pretty hard even for me. So yeah, my name is Mihail, and I represent here Zitec, but the case study that I'll present, it's actually a customer success case study that we've been working on for the past 1 year and a half. And another, asterisk to my presentation is that I'm actually a business line manager, so while I'm technically curious and have been working in the IT area for, I don't know, like 15 years, I never been the hands-on person. So for this presentation in particular, I spend a lot of hours of research talking with our customer, talking with our cloud team, talking with our DevOps team to really understand, all the components that have been involved in this project and all the specialties and all the engineers that have been working collaboratively together. So, sorry, maybe like this. Okay. So for this this presentation, we want to highlight, 5 key areas that we've improved for this project. So it started as a small project inside, so it's called Cars2View. It started in a company that is it's a car dealer. It's called Cars2Click. And last year, after being, I don't know, for 12, 15 years, I don't remember exactly, in the car industry area, they had a click. They realized that actually in this market, there is no point of reference in terms of having actual and accurate, up-to-date information on which to take, business decisions. Like in other areas as well, there were data structured once per year in several countries, or maybe twice per year in other countries, about the market, about what cars are out there, what are their prices, how do they vary. So the idea of the product was for them to launch Cars2View that would gather all the information, first in Europe and then globally, and to have it structured by countries, and to be updated daily so that they can offer to car dealer companies, to offer to assurance companies, banks, or companies that have car fleets that they want to sell or they want to purchase, to offer this B2B platform where the information would be really up to date. They wouldn't have to wait for 6 months to have accurate data, or actually data that in few months gets outdated as well. In 1 year and a half since we've been working together, they have extended the use cases. And of course, here you cannot see that much information, but basically here, for example, is Germany. And what's written here that cannot be seen is that, for example, right now, from what they're scanning, there are 1 million cars online to be sold. So this is from the platforms that they gather information from. And then this is how many cars they have been sold in the last 30 days. There are many information that they gather, and there are many types of queries that a company can run in this platform. They can, for example, look for a particular car model, or they can upload their entire fleet in the platform, and then they can have quotes applied to that car fleet, depending on the country where you want to sell. Or you can get recommendations to sell your fleet in another country than the one you are right now, because in the other country you can get a certain extra margin in terms of selling that fleet. So this is the business case. This is what the customer wanted to achieve, and their goals were pretty ambitious. They started pretty small. It was just a product that they didn't know if it was going to work or not. So after the first few months, because they were running, they started, with their traditional hosting provider. They were happy with it, so there was no problem with the needs of the actual website and other services that they had online. But with this new product, they kind of run into many bottlenecks. So that's the moment when they came towards us. It was interesting because during the break, I've been involved in a few debates. It's better on-prem, better on cloud, where is cheaper, and things like that. Also fueled by the presentation that Alex Bordet had previously. So we actually don't stand on any side. We're looking at the needs of every particular project, and depending on that, we choose the right on-prem or cloud, and then if it's cloud, we're cloud agnostic. So in this case, the customer came with some specific challenges that they faced during the first 6 months of the project. In this period, they scaled from 1 country to 6 countries, and they already had quite a workload that they were scanning in terms of ads. So they were scanning like 1.5 million ads, and the goal was to gather that data as fast as possible. It's daily, but they didn't want to spend an entire day to gather, process, and serve that information in their application. So every time they were bringing a new country, every time they were increasing the number of processes that they wanted to apply for the data that they had, they were facing scaling costs and scaling time. Yeah, so there were a combination of dedicated servers with VMs and lack of infrastructure control, because every time they were coming with new requests, they never knew what to expect up front. And then also the company that they were working with was actually every time coming with new and different solutions. Lack of automation and lack of DevOps expertise. To understand, when they started the project, they had only 1 dev. Yeah, so that small the project was. And then little by little, they added to the team, right now having 4 devs. And we work as an external DevOps team for them, but we're not dedicated, we work on requests for them. So those were the challenges. The performance that was at the time when we started the discussion, they were scraping around 1.5 million car ads per day, which they were stored, meaning the ingestion and the collecting part was done in 3 hours, and then the extra processing in terms of labeling the data, translating the data, because they were scanning data from 6 countries, and each country had, various structures of data. Actually, each site had a different structure, and then because they were scanning only for public data, and applying all the processing that they need at the time, it was taking 2 more hours. 1/10 of processing operations is in relatively to what is happening today. So that was the volume of operations at the time. And yeah, as I said, 6 countries. Now, the goal that they had was to scrape 5 million car ads per day. But again, it's not an entire day. They wanted to do that in less than 60 minutes, starting from, which was at the time, 3 hours. Then optimize for dev users. I've seen earlier that, of course, you don't involve DevOps in the first sprint, yeah? So you don't automate things, you don't work at the CI/CD pipeline in the first day, but maybe in the last day if you have time, as Horia said. But at one point, you need to do it, right? So that's how we get involved to continuously optimize their CI/CD pipelines and infrastructure as code to make sure that their dev team can focus actually on developing and not enriching their skills in terms of DevOps. Minimize running costs. At that moment particularly, they had challenges, I said, with that because their costs were continuously increasing. And we needed to start also with the end goal in mind, which at the time was they were estimating that they would get up to 20 million ads per day. It's still not the case. Right now, sorry, yeah. Right now we are at the 5 million gap, but the solution we've implemented, it's ready to scale up to 10 to 20 plus million. Now, starting from that, we've identified 5 stages to optimize this big data project. And I'm gonna take them one by one, not here. So, yeah. Stage 1, improve ingestion and collector. I've heard also from Horia that he's a big fan of cloud functions. In this case, it's not Google, it's Azure, but yeah, exactly. Hashtag Horia hashtag. Okay, so here I will just go through the technical stack that we've been implementing for this particular use case, and then step by step I'll go into more details. So this is for the ingestion, then for the collector, processing, and last but not least, storage. I'll try to cover as many iterations as possible from the research that I did and by interacting directly with the customer who owns the development, our team who owns the cloud implementation and DevOps implementation, but probably there will be some aspects that I will miss along the way. I will see if at the end we will have a few minutes of Q&A. Unfortunately, the technical lead from the customer couldn't be here. So yeah, probably we'll be able to cover DevOps related questions, which is actually the topic for today. Okay, so this, there were several iterations to reach this technical stack, and then for each of the solutions that we have here, we had several iterations to really get to the point where we are today. In terms of the way we've implemented. So let's take them one by one. I don't know where. Okay. So I'll go first through before and after, and then I'll go also to an architectural diagram showcasing the current workflow of data. So before we were at 6 countries, and now we are at 16. There were 1.5 million ads per day, and now they are between 3 and 5 million ads per day. We were talking about 3 hours ingestion time, and right now it's less than 30 minutes. This 30 minutes actually, it's accumulated in a longer period of time, and I'll detail that more in the architecture, because we have batches which are scheduled a longer period of time. So the time frame, the time window, it's like 3 hours. But if we aggregate the exact time it takes for ingestion, it's 30 minutes, less than 30 minutes. As I said earlier, in the existing infrastructure and with the existing consulting team at the time, the hosting company, there were continuous limitations. And every time a new 1 million, let's say, ads that needed to be scanned, they were more technical constrained. While with this solution, We are right now at around 1,000 inserts per second. And in terms of usage and the potential to scale up right now, we are about 20%. And this is with us being around 5 million ads per day. Okay, it was an infrastructure, VMs and bare metal, which was not difficult to scale, but actually difficult to scale and have controllable cost, or not to add too much cost when scaling every time. I mean, comparing with just extending a container for, let's say, 1 hour, or you know, like it is in Kubernetes, because we have also a layer of Kubernetes. And so the flexibility that we have from both Kubernetes as well as the Azure functions, which is actually serverless, and we play, you know, for the usage only. So if we use it for 30 minutes per day, that's what we pay for it. We don't need to pay for the service for a longer period of time. Okay. And yeah, last but not least, the fact that we have very mature APIs to be working with allows our DevOps team to jump in at almost every sprint. They work in sprints, and we are, you know, every time they need our support, which can be weekly or monthly, we jump in and we add the needed functionalities, the needed automations or implementations. Okay, so I said I'm gonna get to the architecture part. So this is generally, you know, the workflow that has been implemented, and even though I didn't mention about Zeit so far, this is a very key component because it's actually the one that does the scrapping. So instead of them needing to develop, you know, a robot that would scan the internet for this particular information per country, they use this tool. I didn't research that much about it, but few of the cool stuff is that he has adapted algorithm per country, meaning that, for example, if they scan some websites in Romania, let's say out of it, they know which kind of robots are allowed. Because there are websites that don't allow, for example, business registered IPs, but only domestic IPs. So the guys from Zeit, actually the team from Zeit, they're pretty awesome and about knowing these kind of things. Also knowing how they can get banned at each website by being detected their robot, and they know how many scans they need to schedule in certain batches, and after how long they need to have a pause and then another batch. So they do all this smart work in terms of scrapping. Yeah, so we actually don't go there. When we start working is actually when starting to have to process all the ingestion from those websites. And here, again, we also need to schedule the batches, and that's why we have a timer here that schedules the batches per country. From here, we trigger, you know, let's say Germany's first, then Austria after a certain amount of time, and so on and so forth. And yeah, this entire process, as I said, can take several hours, but in terms of specific time for ingestion, it goes below 30 minutes here. And then for the second part, in terms of processing, I'll continue in the next slides. In terms of Azure functions, I wanted also to mention that we've ended up using the premium features, even though we started with the free tier, but we've reached some limitations because we wanted to process this high volume of data in a very short time. So one of the limitations that we faced was in terms of the resources that those resources had allocated, and it was 1 CPU and 1 gig of RAM. And then another advantage that we took seriously was the fact that the premium plan offers pre-warmed up workers. So there is no idle time when triggering them. And this for, I don't know, you cannot probably see. Here the threshold for daily usage is maximum 22 euros. Yeah, so this is the total for 1 month, 494 euros. Now, depending on how much usage is generated by the volume of ads that are scanned every day. Yeah, so there are days like this when there are less items scanned, or days like this when there are more ads scanned. That's why also the range that I put initially, 3 to 5 million ads per day. Yeah, so after improving the ingestion and collector, now the second part was to improve DB performance, but also the processing. Here, the processing part, because we wanted to store data in the database that was already processed. So if we look at a batch of 3 to 5 million ads per day, the processing number of events is between 30 and 50, so it's 10x. So with that big amount of processing, we didn't want to push that many operations that would happen after storing the data. This way, we would end up actually serving the data much faster for the end customers, yeah, the B2B customers that are using the Cars2Click application. Through the setup and architecture that we've implemented, we managed to serve instant data. Yeah, so the processing time was 2 hours. Right now, it went below 10 minutes, processing time in total for the daily batch. It was between 3 and 5 million events, and now it's 3 to 50. And yeah, as I said previously as well, with the previous infrastructure, we also managed to have more control, and also for the customer to have more control. Yeah, it's an Azure subscription in this case, and actually the customer, has full control over the resources there. They have full control over the cost dashboards. So all the resources and all the infrastructure components are actually managed by the customer. Now, in terms of MongoDB, it was very important in this case particular not to go for a managed service. Yeah, so we went on the first stage, we went with Azure Functions, which is, like serverless, and it's fully managed by Azure. But in this case, we wanted to have full control over the infrastructure setup for MongoDB in order to optimize it for performance. And starting from this, we chose this kind of machines, with L being optimized for storage. And actually the key component here, because we looked at IOPS, is actually the NVMEs. Yeah, compared to other resources that they have in their cloud, which are, as we will see in other scenarios, optimized for other kind of operations. This is the replication setup. One thing with NVMEs, especially in Azure, is the fact that they're ephemeral, and they're, I don't know, once every 6 months. From what we've seen so far, there are some maintenance operations that can affect the availability of those nodes. So when that happens, we lose the machine. So we wanted to make sure that besides the fact that we have a cluster, primary, secondary, we also have another secondary which is persistent. This is with low storage. I mean, it's low performance storage, but the advantage is that we have always a copy of the data here. In case anything happens with here, as I said, like close to 6 months or something like, there is maintenance operation. Now, stage 3, it's optimize also the application scaling. behind everything, there is application that they are actually developing. I've showed you the architecture in terms of the data workflow, but in terms of the application that is being developed, there is the one that they're developing. And for this one, initially it was a monolith, and when there were the high loads in terms of ingesting the data and then also processing the data, there were some bottlenecks in terms of how the application was behaving. So we were being able, in terms of workflow and processing the data, to bring that high volume, but the application per se was having congestion in terms of the resources that needed to use. So that's how we came with the double mix of microservices and Kubernetes. It's been actually it's an ongoing project for the development environment. It's been implemented and tested throughout the way, and in production it's there, it's been deployed, but it's not yet live. So this is actually one of the projects that we're still working on, and in the next few weeks we're gonna switch in production as well. So the application has been split in smaller components, and then for each component we've been working to analyze through the stack of Prometheus and Grafana to understand, to monitor and to understand which components need more resources, when do they need those resources. And while initially we had only one VM allocated for this, yeah, it was this VM. Right now at the peaks, the Kubernetes nodes are scaling up, and the application can go in the Kubernetes cluster up to 3 of such VMs. So the performance that we've achieved is also due to this switch that we did. But as I said, in production is only tested, but it has not been fully deployed. Cloud automation. This is actually the part that we at DevOps, are working on continuously. The others are just projects that we work on from time to time. But this is like a weekly effort that we put in, and we go hand in hand with the effort that their development team does. So these are all the components that we are working with. As I said previously, for example, in the AKS cluster, we've implemented Prometheus. There is an S there with white, and Grafana, and yeah, we've automized everything in terms of IAC, working with Terraform for VMs, AKS or Redis, and then the technical stacks vary a little bit from backend to front end. In Zeit, it's Python, so the programming language that has been used also for the Azure functions, it's also Python, while the front end is different technological stuff on JavaScript. So last but not least, there was a huge load from the logging side, because every time that number of events that was processed on a daily basis, 30 to 50 million events on the processing side, was generating a high volume of logs. And the first implementation was done also in MongoDB, so there was a lot of workload put on MongoDB. So we've decided to do again a migration, and again, it's about having AKS and having Elasticsearch deployed in AKS. I won't go into the details, but the performance has been significantly improved, and also it removed from the workload that was put on the on the database. So yeah, I think if there are any questions, I hope that I can answer, or my colleague Daniel, as I said, is from the DevOps team. So depending on the questions, I hope that we're able to answer them, and we won't need the dev side here, which is, as I said, the customer. No? To be
Great.
honest, I will be glad.
Okay then, thank you, Mihail.
Thank you as well.